The first speaker today is Professor Luís Bettencourt. He is the professor of complex systems at the Santa Fe Institute at the US. Now, he was trained as a theoretical physicist and obtained his PhD from Imperial College, UK. And he studied statistical and high-energy physics model of the early universe. So he's coming down from the space to the planet Earth. And he has held postdoctoral positions at the University of Heidelberg in Germany, Los Alamos National Laboratory, and MIT Center for Theoretical Physics. Now, he has worked extensively on cities and urbanization, though he is trained as a theoretical physicist. So we have some other theoretical physicists who turn their attention to human systems. Okay. Professor Bettencourt is a typical and outstanding example of it. Okay. So his research emphasizes on creation of new interdisciplinary synthesis to describe cities in quantitative and predictive ways. Of course, the study is informed by empirical data also. So his research interests also include the modeling of innovation and sustainability in developing human societies, the dynamics of infectious disease, an aspect of general information processing in complex systems. So he's particularly nowadays interested in the interplay between information, scale, and then complexity. So to sum up, he is an expert in complex systems. So for his achievement, he has received many awards. Okay. And then published in high-impact journals, such as Nature, blah, blah, blah. Okay. So without further ado, I would like to welcome Professor Bettencourt, to give us his lecture. Okay.
Thank you. Thank you, Professor Long. How's the sound? Can you hear me in the back? Is the sound okay? Okay, thank you. So thank you very much. It's also a relief for me to be here and a pleasure. Could I bring up the slides? Sorry. We had them there before, so hopefully that'll work. So Hong Kong is really one of the great cities in the world. In many ways, as you know, in this part of the world is really where, when we talk about urbanization or we talk about global change, this is where it's happening. And Hong Kong is, in many ways, the poster child and the experiment and continues to lead the way as to what that change looks like and its consequences both for people and development, a better life, but also the challenges that come with it in terms of our resource use and so forth. So I don't think okay, sorry. There we go. So we got the slides now. Good. So it's a special pleasure to be here. I always look for Hong Kong for examples when we look about issues of density, issues of transportation, but also issues as to what sort of the Asian city, the maybe Chinese Asian city could look like. So in my work, Professor Long already mentioned this a little bit. I've been always fascinated by people in cities despite my sketchy background in physics. And so I've been very interested in really thinking whether we could understand these systems in ways that they're not just descriptive, they're not just qualitative, though sometimes that's necessary, but also somehow emphasize what's common about all cities everywhere. And this is a special time in history where for the first time the entire world is becoming urban and where we can start making those comparisons and understanding what a city is like and how cities change human societies and the world more generally. So let me start sort of on a historical note. So this is a very famous photograph. It was taken 48 years ago, almost 50 years ago. It's called Earthrise. It's one of the first photos of the Earth as a planet from the outside, from the moon. It was taken by Apollo 2008 on, I think, December 24th. And this photo actually is considered one of the great achievements of this time. It's the first time that we look at the Earth as an environment, as a single environment. And it marked a lot of how we still think about the environment in cities and global change as a whole. But of course, so this is now coming down a little bit to kind of honor my own path of coming from the early universe to cities. You see that we're coming down a little bit. We're now in the space station. And when you're in the space station and look at the Earth at night, this is kind of what you see. What you see here, we're going down the Americas. So this is LA, and I think we're about to see Mexico City in a little while. And then you're coming down the Americas. And the feature of looking at the Earth like this, of course, are these immense parts of light that you see coming out. They're very concentrated in space, and they're, of course, cities. So this has almost become a geological feature of the Earth. And it is really in these places, as you know, that not only people and energy use are concentrated, which you see directly from the light, but where a lot of other things are going on, where a lot of economic value and innovation are even more concentrated. So I'll tell you what that means by more in a few minutes. But so the whole idea really is that there's something extraordinary happening that we just became conscious of in many ways that has to do with this enormous concentration in space of people, innovation, resources. And this is really now a global feature that's changing the world. And the change that you see, of course, can be spectacular. So this is Shanghai, just to evoke a little bit the region here, but it could have been Hong Kong with different dates. But this is about 25 years, right? So, and it's like a whole other lifetime, a whole other history, right? So cities are characterized for this, right? They change. Not only do they get bigger, of course, not only do they use more resources, you see how everything is lit up in Shanghai in the second photograph, but there's sort of an informational change. People are doing different things. They are creating different kinds of economic value. They live in environments, physical, and the way they work, they are different. So this is, again, then this articulation of how scale, so the size of things, and how information are really connected. And cities, in some way, ultimately are about this, are about sort of a transformation that connects scale and form to a certain kind of function. And this function is really to create change and development in human society. So throughout this talk, I'll be riffing on this theme as I give you examples that are a little bit more definite. And I start going through the properties of this process. And I think it's from understanding this process that we can both create sort of a science of cities, but also create applications, ways of intervening in cities, ways of measuring cities that make sense in this, and that can be useful in terms of producing urban environments that are more livable and more productive. Now, with all these great things that happen in cities, bad things also happen. So we can have a lot of traffic. This could have been anywhere. I think it's Beijing, but it could have been Latin America. It could be parts of Europe. It could certainly be parts of the US, like if you look at Atlanta or LA. This is Rio, but as you know, one of the issues with urban transformations is that they create also relative poverty, that even though life improves for most people, there are issues of whether it's improving fast enough in the living conditions of many people. This is very hard to see, but I think it's Tianjin, and it's issues of air quality, which are important here in the region, and of course are becoming an issue that we all would like to address and make work better. And so let's now get to this issue of why is it that cities, I just want to show you in 2 or 3 general slides, what is it that cities are doing that's not just creating these shapes and these urban environments that you see as physical environments, but they have to do with kind of a qualitative transformations in people's lives. So what you're seeing here in this slide, this is from a UN Habitat report from a few years ago. You've seen basically there is the Human Development Index, which is a measure of income, but also of health and education. And what is being compared there is countries in blue. So those are different countries that kind of not shown explicitly, but you can kind of read it from the cities. And then what you see in orange are basically the Human Development Index for cities. So some of the cities are indicated. And what's extraordinary about this is that in each country, you will find that in terms of income, education, and health, people live better in cities than they live in the country as a whole. Okay? So when we sometimes think about how cities are attractive because perhaps people want jobs, there's a lot more going on that has to do with the whole life transformation that these places are creating. So you see also some exceptions that speak to these problems in cities. Some of these places are places, the pointer doesn't work very well, like Monrovia, which are very poor. And if you follow the news of the last few years, it's one of the places of the Ebola epidemic was most severe. But by and large, this is a general trend. You see, for example, some of the cities of India or Africa and so forth. So cities lead the way in terms of creating this transformation within their countries. This is another way of showing something similar, but this now is about money, just money. And so in different colors, you see the trajectory of different countries and how much they're urbanized, so how many people live in cities by some definition, so that's the x-axis. And in the y-axis, you have GDP per capita, sort of as a measure of wealth. But as you know, it's connected to many other things. And so what you tend to see is these sort of lines that span the diagonal, so they go to the right and they go up, which is a process indicating how urbanization is creating wealth in most countries. But if you look carefully, there are a couple of features that are sort of interesting. One feature is that if you look at Brazil, sort of the purple line there, you'll find that you can have urbanization without wealth creation. So that's sort of interesting because this can happen, and it's not very well understood. Why exactly is it that the processes that could happen in cities? Sorry. What are you looking for? That's mine.
Oh, yes. It's amazing.
It does, but it's not very strong, so that's the problem. It's okay. If you have another, I can use it, but it's okay. It's not essential. But you can also, let's see if I can do the jog. Okay. So you can also see that, countries like, this plot has some problems with the data, but just, you see that places like China and India, which of course are the countries where most humanity is experiencing very fast urbanization. If you extrapolate these curves, they're ahead of all these countries, right? If you take them here, they will achieve a level of wealth that is higher at lower levels of urbanization that has happened, for example, in Europe or North America, which is very encouraging. It means that we're creating progress sort of in many parts of the world faster. But you also see countries that are very urbanized, like Germany or the UK, that are urban enough that they can now produce growth. So at some point, of course, this is a number that goes to 100%. You cannot keep going. But once you have cities, you kind of have this mechanism of change also in terms of economic growth. Okay, so this is sort of interesting. What is this process and how is it happening? This is ultimately what we want from cities, right? We want improvements in wealth. We want improvements in health. We want improvements in longevity. We want improvements in livability. And this is sort of a different example, but just to give you a bunch of them. This is from India. And it's electricity access. We're doing a lot of work in my group trying to understand cities, for example, in India. The data is difficult. But what you see is that these are larger cities and these are smaller cities or rural places, as you can see. It's a classification that's peculiar to India, but there you go. You see that the levels of access to infrastructure and services, this is just one example, tend to be higher also in larger cities for all kinds of reasons. It's just easier to provide these services, but also urban populations tend to also want them. That's one of the reasons why people come to cities. But just to give you, sort of close this first introduction to a bunch of transformations, there are a bunch of other things that are happening that's sort of interesting. I find this one amusing. It has to do with adaptation to these urban environments. It's not about people. It's about pigeons mostly and other birds. And it says that birds that are kind of smart, that can find ways of eating the food that we eat and our garbage and so forth, adapt to cities. And these are actually not just any birds. They're smart birds. They're birds with big brains. And so it's sort of interesting to see how sort of this new environments and complicated niches play out. And this is for New York. It's from BBC, but it's about languages. There are more languages spoken in New York City than anywhere else in the world. Many of these languages are dead in the point of origin, but still exist in New York City. So again, cities are not creating these environments that are homogeneous, where everyone does the same thing. They're creating environments where they're extremely diverse, where people do all kinds of different things and are interconnected. Okay? So one way to start looking at this, and you know my work on scaling, but I'll just show you some examples now, is to start asking, how do these properties, some things we can measure, which will always be a little simpler than all this diversity and wonderful things that happen in cities. How do these things change, for example, with city size? City size may be population. Closely related is the area that cities occupy. It could be other measures, but it's a measure of scale. So here comes the theme of the lecture. So one of the things that you see, just to continue with this theme, is that if you look at what people do, what are their professions, and you know this very well here in Hong Kong, then if you look at large cities, so this is all U.S. cities, and this is population, so we're looking here at New York and LA and Chicago and so forth. And this is basically the number of people occupied in these professions. These are called, by the people who invented them, Richard Florida, super creative professionals. So people like you, you're super creative, I think. Congratulations, I think. Comes with a price. But you do, computer, mathematical, science, managing, media, and so forth. And so what happens is that as a fraction of the population, more and more and more people do this in larger cities. So these are basically functions where people are creating information and connecting people and managing information in ways that seem to appear less as a function of work in other cities. And so the question really is then, if all these transformations are happening, and they're happening together, right? So we're talking about cities getting larger, getting richer. These two effects are not necessarily connected. You can stay the same size and get richer. That usually happens, as you saw for some sort of places in Europe. But they're also changing the content and the activities of people. So one of the questions really is, what is this process? Can we describe what this process is in some way that starts to be predictive? So the next little bit of my lecture will be about that. What is that process, what we know so far? And then the last part of my lecture, I'll spend a little bit of time then on cities in China and Hong Kong and Singapore, because I had some data and I took the opportunity to just play with it, to ask you questions. And then I'll spend some time looking at opportunities for data, theory, sensing in cities towards the end of my talk, just to get us there. Okay? So one of the questions was really, can we understand this form organized complexity? So Professor Long already told you that I come from a Complex Systems Institute. We like problems where a lot of these features, information, scale, diversity, are interrelated. And so that's what we want to try to understand. But she was actually working in the 60s at a time that's interesting to ponder, because in some ways history repeats itself. And this is a time of great transformation in cities in the United States and Europe. Sort of it's the post-war. There's a lot of investment in cities. It's also a time of crisis in cities. And people were trying to solve the great problems of cities through massive infrastructure interventions. Some of the things that you see in China today, for example. So build lots of roads and lots of buildings and lots of infrastructure quickly, but in the hope, I think, if you give them credit, that such infrastructural, spatial transformations would make people's lives better. But at least certainly in cities in North America, such transformations were not very much informed by theory. They were informed a little bit by design and people's preferences. But they created, in fact, cities that were very disconnected. They use a lot of energy in terms of transportation, cars, et cetera, and that created a lot of concentrated wealth and poverty, so disconnected cities in many ways. So it's interesting to revisit these ideas and look at how is it that the complexity of cities informs us as how they work as interconnected networks, so that we don't create the designs or solutions that may actually destroy those features rather than create them, because we have the wrong ideas sort of in our minds. Okay, so the organized complexity of cities is Hong Kong incarnate, right? So this is a photo of, I think, downtown Hong Kong, and it's again the same thing. There's a spatial and temporal process. People are moving around. Things are moving around. There's a lot of information. There's a lot of economic activity. There's a lot of signaling. And we want to understand how this process really works. Okay, so Hong Kong is really exciting because you if you have these things in your mind, you want to know how they work, you just go to a street corner. If you don't get nudged by people moving around to share the world, you just see it, right? It's happening there. You just go like, okay, I'll write the math, right? Okay. So let's talk a little bit about how historically we thought about these ideas. It's also fast. I like Hong Kong because people are fast. There's always something going on. And you kind of have to decide quickly, which is not good if you just stepped out of a plane that took 14 hours. Okay. So people thought about the relationship between, again, scale and space in terms that are relatively simple, but that stay with us, and there really are the foundations about how we still think about this now that we have so much more information. So let me just give you a few ideas. You probably know about this if you come from planning or economics, but just to set up the stage. Okay? So this is the most classic, oldest model of anything spatial in economics, right? It's the Fontuna model. And it's a model that's not about cities at all. It's a model about a market and where things are produced that come to that market. And he was really, this is almost 200 years ago. He was in Germany, and he was looking at his town, and he had, of course, land, and he wanted to know how to make money with his land. But he was looking at how different produce were coming to market and where they were produced in the land around this market in a town, okay? And so he was thinking about, sort of as the example shows there, tomatoes, potatoes, wheat, so agricultural products. And so the idea is that if any of these things are easier to transport, then they can be done further and further away, right? And still be brought to market. They don't cost so much to be transported, and they can be sold in the market. But if something like a tomato, in comparison, is hard to transport, may be damaged, and it is high value to begin with, a tomato by mass is worth more than wheat, then it should be produced closer to the center, closer to the market, closer to the center of town. So that was what he observed, and basically you can do a very simple argument that says that depending on the rent, so the money that you get from each one of these products, and you have some costs of production, price minus costs, and you have transportation, you can basically see that that this should decay with transportation. So basically what you're seeing there is a line that's going down like this, and that's R is in here. It's showing you that things that have lower transportation costs will be shallower, so it can be produced farther and further. And later on, almost a century after that, in the 1960s, there was a man called Alonso that many of you know a lot that thought about this. This is exactly how a city works, maybe. It's kind of like a city works, which is that if you think of people and industry and manufacturing doing different things, and we all have to interact somewhere, of course, to go to work and to exchange things, then we should organize the city in certain ways that certain things that can be transported be in certain places and so forth. So the whole idea is that you could think of a city and you could think of land uses in this way. That, for example, things that are very intensive about people and high value, like finance, will be in the center, but perhaps things that can be transported, like manufacturing of goods, physical goods, maybe a little further away because those things can be transported and they don't break. And you know, if you put people close to that, maybe that'll work. So a lot of economic theory came from these ideas. So these ideas now are a sort of set of people living in space, exchanging services and things with each other, but organizing these activities relative to each other in a way that minimizes transportation costs. And that's basically the calculus of a city in terms of economics. If you look at most economic models of cities, they still work this way. They're more sophisticated than what I described here. But that's essentially the logic of it. It's trading transportation costs for land rents for types of activity with different values and putting people in all the right places to do that. A lot of zoning that we do in planning is related to that, either because of health concerns that should separate people from certain activities, but increasingly because of issues also of transportation. Oh, wrong one. Okay. Now, cities now are much more complicated than that. And so one of the challenges has become, how is it that we even understand cities on a large scale? Michael has done a lot of wonderful work on this for a long time. But there's really a worldwide sort of, I think, approach to how we do this that's becoming possible. Hong Kong's special because, as you know, we have a very hard boundary. But in some ways, you're increasingly more and more integrated with Shenzhen and other cities in Guangdong and so forth. But the whole point is that as we look at these very large cities and we think that the cost of transportation is now very cheap compared to the money that we make, these cities become more and more extended and become very large spatially, but also acquire different shapes depending on the type of transportation. As you know, in Hong Kong, you have good public transportation, can be very dense, but in the United States, we have a lot of people use cars, so we're much less dense, but people move faster, at least when there's no congestion through space. So the idea is to create these kind of definitions that have this property of connecting space that people can access from the entire region of a city. And these are called essentially functional cities. And they're the cities that have the properties that I discussed with you from the von Thunen model, and that I'll show you later. So when you use these kind of cities that have this property that connect everybody that could work together, you start having these sort of properties that essentially are telling you a lot of what is the logic of cities. So what you have here is wages, so the money that people make in American cities again. I'll show you Asian cities a little bit later. And this is over time, and I did a trick here that I'll show you later a little bit more explicitly for Chinese cities. But it's basically that I removed both population growth, which would be here, and GDP growth or wages growth. So I basically put that the center of this line, which is 0, 0, for each one of these years. And then once you do that, you just put all these years together in the same curve. And so, for example, this is New York City. So you see that it started there, and over time, once you take away the population growth and economic growth at the system level, nothing much happens. It just stays there. And this is what you're seeing for all these cities. And what's interesting is that the general trend, the average trend that's represented by this line, is showing you that this line has a slope greater than 1, which means that people make more money and spend more money in larger cities. So this is a general characteristic. We call it superlinear scaling, but it's something that economists tend to call agglomeration effects. And it's a very special kind of thing because it's telling you that in larger cities, whatever it is that people are doing, and you know what people are doing because we already discussed it, is different and gets more value to labor than in smaller towns. And so this gives you an immediate reason for why people may prefer to live in a larger city. But of course, if you figure out costs, you'll see that it's not so simple. But that's one of the effects that's very important. And when you start to see this, so when we started our work on sort of this kind of data, we did a lot of these. Many of us that know me for a long time know that we've done a lot of these. And so we looked at many different countries. And so let me just give you sort of a quick highlight of what one always tends to find. So this is sort of the other effect that's very interesting. This is the surface of roads in American cities. And so it shows you that this line now is below the line of one slope, which means there are fewer and fewer, there's less and less road surface per capita the larger the city. So basically the city is getting denser, but in terms not just denser overall, but denser in terms of its built infrastructure. So there'll be more people in general on that same amount of road, and that's why you get more congestion. But the city is growing in this way that's not just adding the same amount of space per person as it gets bigger. It's actually growing in a way that's density dependent, and it's increasing that amount by a little bit less with each person that joins. So this is why you can get to extraordinary densities like the densities in Hong Kong. If you think about the history of Hong Kong, you were showing me from the view yesterday that the first people to come here had little houses. And so they lived with more space. But as more and more people came, of course, you know that each person has a little bit less space. Perhaps it's nicer space, but it's a different kind of space, okay? So that's the idea. And here on the right, it's the same that I showed you before, but instead of wages, it's now GDP. And you find this effect that it tends to grow faster than population. So this is basically the classic agglomeration effects in economics. It's telling you that everything's being produced in larger cities is more valuable, both labor and both in terms of profits. But what's interesting about this is that the number that tells you about how this is different from one below is similar to this above. And it's a number of this order, about 1/6, as you'll see. So here's just a few other examples that show you that this applies to a lot of things. So this is still the same thing. It's GDP, but now it's European cities. Most cities, this again, the kind of definitions I showed you from OECD statistics. But if you look, for example, cities like Berlin or Naples, they're below this line. And it's sort of interesting. You can use this to see how well cities are doing. If you look at urbanized area, which is similar to road surface, you find again this. This is the line of theory that I'll tell you a little bit about in yellow. This is employment. It tends to be simpler. It tends to be 1. So basically, the same fraction of people are employed. Doesn't matter what the size of the city is. But actually, in China, this is a little different. Because in China, because of the hukou system, forgive my pronunciation, the work permit system, you'll find that actually families often don't move with workers. And so you tend to have a different effect here that's very interesting. And then this is, for example, patents, so measures of innovation and information creation. And this is always a noisier quantity because there are not so many patents, but you see a similar trend. There's a different trend with a different number that's also very interesting. I've heard many of you complain is not the right word, but basically talk about how expensive housing here is in Hong Kong. And if you look, this is a characteristic of all cities. I mean, you can go to every large city almost. Maybe Chicago is a bit of an exception. And you can ask people, do you think housing is cheap? Right? Go to London. And everyone will tell you, no, it's very expensive. I spend all my money on housing. So this is typical also. But actually what's interesting about housing, these are single-family houses, so it's a little different, is that it increases faster than incomes. And this is why it creates such difficult problems. So what happens here is that there are two effects, just to give you a sense of what's happening, is that both the city is getting denser, right? So there's less space per person, but also it's getting richer, so there's more money per capita. So if you ask how much money is there per unit of space, per area of space, then this number compounds these two effects together. And so this elasticity, this exponent, is about 1/3. So this means that unless you start building high, and you know all about this in Hong Kong, creating effectively more floor space per unit of land area, right? So that's what a building does. Then you have this problem that basically the price of land just skyrockets and outstrips incomes. And this is something you get from this perspective, okay? And this is done with Markus Schlepfer, who's now in Gerhard Schmidt's operation in Future Cities Lab in Singapore. And it's about basically, as far as we can measure, the links in a social network. So basically, judging from cell phones, this is my native Portugal, you have basically the same effect, that the number of connections that people have in larger cities tend to increase faster. So if you live in a place like Hong Kong, you may know more different people than if you live in a smaller town. That's the expectation. We've now done this with cell phones in many other places because this data is more or less readily available. And it seems to always be true, but we would love to be able to do this, of course, in the actual contacts that people have physically throughout the day. Okay, so this is all to say then that there's sort of a logic to these processes. Now, first I gave you the ideas, then I showed you a little bit of the data. But the logic is the following, is that cities seem to grow in this way that tends to increase density. And this can be understood by this interplay between the cost of moving around and the size of the population. I'll show you with a graph in a second how that actually works. But this means basically that you could think of a city in the first approximation as a mixing population. Anyone in principle can meet each other. It's not that simple in reality, but something like this. But the amount of mixing in people you actually meet is conditional on how much you can afford to move around given the value of your time in transportation. So that's the first assumption, which is very important, and really comes from thinking about epidemiology and health models. The last feature is basically what I already told you, is that it's by computing the expected number of interactions that people can have with each other in this space that I just described, that you get these effects that can scale faster than population. So you have more contacts per person in these spaces that have basically higher density of people, as you might have expected. But in actual real cities, you have two other effects that are interesting. One is that the infrastructure network itself, the buildings, their height, the roads, everything that you see that we built has this feature that's growing in a density-dependent way and has essentially this exponent, as I showed you. And that people, even though they interact more and have, to begin with, a larger budget, needs to have basically an amount of effort that is constrained. And this we know from social psychology and other measures of effort. But it's, again, something that needs to be better understood. There's a lot of social science and psychology about this, but it's a theme that is a little bit understudied. Okay, so when you put all this together, then let me show you now how it works, and then get a little bit to, let me just check the time to see how well I'm doing. I don't have it here. I do have it here. Too many things in my pocket. Okay, good. That's about right. Okay, so now let's just go through this and see how it works. So think about a city, like something that's very small, just to give you a sense of it. So this is actually a small Aztec village, if you like history. I work with a lot of archaeologists and anthropologists that look at very small settlements. And this gives us sort of a different dimension to think about how even a small village works and gets put together. So these are not planned. It's just people settle down and have houses. And the houses are what you're seeing basically there in orange. Okay? So it's kind of a funny thing, right? That doesn't look a thing like the city, but it just gives you an example. So why does it have that size? Why don't people basically... So that's basically, if you're a physicist, then inevitably, but also if you're an economist, it turns out you'd say that this city has a certain radius, okay? But why isn't it smaller? Why don't people live closer together or bigger, right? And the reason, again, is this argument I already gave you, which is that you can think about this as people moving around and interacting with others. So basically, this is the density of people you will meet in this space. And the cost is basically proportional to that scale, which is how much you need to walk. So when you put those two things together, you basically get this result, which is very cute. And we see this in a lot of archaeological villages. And it's important to just give you a sense of what it means, so very quickly. So the area, this area, is proportional to the population to 2/3. But there are these two interesting facts. One is the value of each interaction you have with other people, how much you get out of it, in some sense, how much you earn per interaction. And if this gets bigger, you see that the area gets larger. And the reason for that is that you can afford to put more money into moving around, for example, in faster transportation. This number, on the other hand, is the cost of moving around. So if the cost, for example, is lower because it's easier now to have a car, then also you see that if it's lower, this gets bigger. And this is what a lot of this is what's been happening historically in cities, is that the cost of transportation relative to incomes is now lower than it used to be in history, and so cities are getting larger spatially. In Hong Kong, of course, you have issues that you cannot get too much larger, but in many other cities you'd see this. Okay. But cities, in fact, don't work like that. They have this organization that's actually very peculiar and special to cities. It's different from any other complex system I know of. And the organization is basically this, is that this is an old map, as you can see from old York, not New York. But every city looks like this, even in Hong Kong. And so what you find is that you have houses, or maybe very tall buildings, but you have streets around them. So each one of these blocks, which will have housings and places of work, will be surrounded by streets. And so you see that there are these two networks, the network of places, which are where people actually are, like this building. But in each building, you can walk out and go to the street, and then go on the street or the subway, and then end up in a building just like this. They have a way to come in and little rooms where people meet. So this structure, regardless of shape, is the same in every city. And that's kind of fascinating. But basically then, allows us to start looking at how this space gets put together in terms of the density of these two networks coming together. And once you do this, you get the right number for why infrastructure grows the way it does. It's just this very simple feature, but this is the way cities always work. Okay, you see this sort of in maps. This is Tokyo, and you see that the density is conditional on, for example, the subway systems and so forth, and the train lines. And then the idea then is to put this spatial characteristic that I just showed you, how space gets built, with the socioeconomic network of people interacting with each other. I'm just going to speed up a little bit in the interest of time. So the idea is that people interact, if I could map your life, right, and ask everyone you know and when you know them in time and when you meet them again and where do you meet them, I could start building the social network of what you do, right? And that network exists in space and time, right? Because you have all these interactions. So it's not really something that's always there. It's something that you built that disappears and comes again. So it's sort of this idea that this is actually something that's alive and changing. Okay? And so if we put her back in space and see, what kind of interactions she has over space, then you can basically have a sense of all the things she gets in life. So this is sort of the organized complexity, or more or less organized complexity issue. And it's through these interactions that in a city people get things. They either get sick or they get healthy, they make money, et cetera, et cetera. So it's this idea that these networks need to come together spatially in order to get these numbers right. Okay? And in a larger city, the same thing happens, but the infrastructure is a little different. There are more people per unit space. And so in the same space, you can do more over the same time and space. And this is basically this effect that over the same time and space, with the same effort, you can do more things with more different people in a larger city. And this is at least at the origin of the amplification effect that we see, and it's consistent with the data that we see. Okay? And not only that, but this forces also people to separate a little bit what they do and become more specialized. I'm not going to show you this data because it'll take you longer. But when you look at professions, I already showed you some examples, people become more and more specialized in larger cities. So what you do in Hong Kong is likely, as you grow older and go through your studies, to become very specialized. It's very strange when you look at what each person does. But as a whole, the system works well. And this is a way for a society to have more information because people, through specialization, acquire new skills and create new value. So what's characteristic of urban societies is that they're very interconnected and very specialized individually, and they're rich. And what you see in subsistence societies, like rural societies or very simple societies, is that people do all the same thing. They may have good knowledge, but it's how to be a farmer or a fisherman or something like this. And they're less interdependent, and it's poorer. So there's a transformation about how you create information in an urban society that has to do with these processes of having a denser network with more specialization and new knowledge being created that then provides value to economic activity, but that needs to be spatialized and needs to be facilitated by an environment that allows that to happen, and that's a city. Okay? So when you see with that is that you can see this in many ways. You'll see some of this next time you go to Hong Kong if you hadn't thought about this, or any other cities, that the infrastructure gets big and starts taking over a lot of space. Because as I showed you, the infrastructure is growing a little faster than space itself. This is why the city goes high and goes low. So you get big pipes. This is in the United States. You get big roads. This is Rio. You start seeing a lot of the infrastructure take over space, sort of very interesting. In New York, this also happened, but then it got buried eventually after a big ice storm where everything fell to the ground. You also see that the city starts getting high. This is New York, which really should be Hong Kong. And this is, again, work with Markus Schlepfer. It's really interesting new work. Mike also did very interesting work on years ago, Phil Stedman and others on buildings and their volumes. But we now have a lot of LiDAR data and other kinds of data that allow us to do this in many, many cities. So we start seeing the three-dimensional space of cities. And we can see, how much height are we creating and what is the shape of these buildings. And you see basically the buildings get bigger and they get taller the larger the city, something you know very well here. Okay, so the message from all this, now I'll move on to a little bit of Asia and then a little bit of outlook, is that even though cities are incredibly complicated, open-ended systems, they're somewhat predictable in exactly the theme of this lecture, which is how scale, structure, and information are related. We're learning a lot about these processes. There's a lot more to learn sort of at a more disaggregated individual level. But these processes are becoming accessible to both empirical study and theory. And we're starting to get to the essence of what cities are, essentially as an engine, as a process that creates these transformations through structure in space and time and how this is pushed by scale. So while we're at a time of great transformation, where we can measure a lot of this and we can interfere with these processes through a technology, in some sense, this is actually changing the way we look at cities, how we intervene in cities by classical models of design. But it's also creating a more natural approach to cities, where it is this informational content of cities, what we know about it, who do we interact with, how the built environment, like what Charlie's doing, interacts with people. These aspects are becoming sort of alive in a way that's more natural to the way cities actually work than anything we've done in the past. So it's a very interesting time for that. So let me just show you now sort of a little exercise that I did on the plane coming here about Hong Kong and Singapore, because I just thought it would be interesting. So this is sort of a messy plot, okay? And these are, but it's messy a little bit on purpose. And it's about Chinese cities. So these, if you know China, I don't know all that much, so you might correct me. These are prefectural level cities, so they're largish cities. These are, the population here is measured by work permits, so it's a little bit underestimated as far as I know, but I'm happy to talk about that. So for example, Beijing has about a population of about 13 million, which is thought to be low. And Shanghai a little bigger, but not so much bigger. And so what you see here is similar to what I showed you to the US, is that, so here's Beijing, and here's time, right? So this is basically 1996, and this is 2014, or 15, sorry. And you see basically these tubes, which is how cities are changing. So they're moving a little bit to the right, population is growing, okay? But they're also getting richer, so you see most of the effects going up. Chinese cities are getting rich very quickly. And I'll speak to the numbers in a second, but you see this is Beijing, this is Shanghai, this is Chongqing, forgive my pronunciation, this is, I think, Tianjin, and so forth. So, and this is the center, so this is the average of GDP, and this is the average of population. So I'll do the same trick. And so I'll move that plot, right, like this, okay, and move it so that all those yellow dots are aligned, okay, and then it looks like this. And that yellow line, again, is what that theory would have predicted, but you see now those cities. So you see, for example, a place like Shenzhen has been really exceptional, very rich for what it is, but also you see it's kind of maybe starting to converge there. I think the population is quite underestimated. It should move that way, but okay. But you see some of the other cities as well. Now, if you ask, where's Hong Kong and Singapore? I had data for Singapore, and I thought it was interesting to include it too. I think, again, the sizes of cities are a little funny, but what you find is that even more than Shenzhen, both these cities are very exceptional if you look at it from the perspective of Chinese cities, which probably you would have expected. And so I thought that was interesting to just see where the heck do they fall, right? But I made this plot like this first, and then I asked, but maybe these cities actually have a life of their own doing their thing, right? Look how it's changing, right? And look how it's changing. But actually, when you put it in the same kind of color scheme, this is what you find, which I found was very interesting. So what you actually are seeing is that because you see that these 2 points, particularly Hong Kong's moving to the left now and down, It means that you basically have population and economic convergence between Hong Kong and cities in China, which is interesting. Still exceptional, but you see the difference. And similarly with Singapore, which of course is more separated than Hong Kong is. So I thought that was interesting. I'd love to discuss this with you. I think the data needs to be understood better. There are lots of things to do about this. I haven't published this, but maybe interesting to think about. So the other kind of thing you can do with this sort of scale is sort of comparison between two cities. So allow me this. Again, I had good data from the World Bank for Singapore and Hong Kong. I think you're sort of kindred cities of a sort, frenemies. So, you know the word frenemies, both a friend and an enemy. It's kind of funny. And so, for example, if you look at GDP of Hong Kong versus Singapore, and you do it in the scale way, you get that basically, look, I mean, these cities have been doing the same thing. This is 1960, okay? So imagine Hong Kong in 1960 if you can, or Singapore, and this is now. So you see basically how these two cities follow along, and this line is the line of equality. If they were the same city, that's what they would do. So you see that they really follow the same line. Singapore is doing a little bit better now, but not by much. And if I put you in the same exact spot in 1960, this is what you'd find. So you start the same in 1960 artificially, and this is what you find. So again, very interesting because we often think, when I talk to my friends in Singapore, they say, oh, maybe we're doing better than Hong Kong. Well, it's very similar. It's very interesting. I mean, of course, Hong Kong is a little bigger and so forth, but okay. This is one that I found interesting. This is CO2 emissions. Okay, so it's the same sort of plot. But when you look, is that basically what happens here, if you put you at the same spot in 1960, Singapore really grew by increasing enormously its emissions compared to you in Hong Kong. But if you look at the last few years, Singapore is doing much better in bringing that down than you are. So I don't know why. I'd love to discuss that with you. It's interesting. This is kind of a different one. It's life expectancy, right? So it's sort of a rough measure of quality of life, but through health. You have an exceptional, life expectancy. It's exceptionally large in Hong Kong, but this is what it looks like. And if you put you the same as Singapore, so you look good, right? Because you look like you're always better than Singapore. But if I put you at the same spot in 1960, it's also very similar. And what this is interesting is that Singapore had 2 years lower life expectancy in 1960, and they've made almost the same progress as you have, and now they're still 2 years below. So this is why this plot is like this. But before I go on, let me just tell you something here. I mean, I don't know if you've been looking at the numbers, but just if you look at these numbers, since the 1960s, so in these 50 years, roughly, 55 years, you've experienced in Hong Kong, in this region in general, also now in China, 2 orders of magnitude, a factor of 100 in GDP per capita improvement. Okay, so you went from about $300, $400 per head to 30, 40,000, something like this, at least by these numbers. So imagine looking into the future, another 50 years. Is this going to happen again? You would do the math, right? 40,000, 400,000, 4 million. That's what it would take. That your kids, in a little bit, when they're your age maybe or a little older, they would earn $4 million on average in Hong Kong. So it's been an amazing time of transformation. Maybe that transformation will continue, but it's hard to imagine that level of improvement will really happen in the next 50 years to the same level. And I'll close in a second with that theme, okay? Okay, so let me just talk now in closing about a few opportunities and things that, about how all of us, I think, lecturers here and many of you are thinking about cities. So when we started this business of smart cities, this is a picture from IBM, it's from Masdar City. A lot of people had this sort of picture in mind, right? So what you're seeing here is a city that's like run all by software systems where energy is all coming from solar and zero, emissions buildings, and everything's synchronized. There are these fancy cars that look like in a sci-fi movie and so forth, and it all looks like perfect in a certain engineered way, right? So this was the initial dream of the smart city. It was the city that really is run by all these infrastructure services that's super efficient and super green. But in some sense, in the last 10 years, it's been only 10 years. I think Smart Cities IBM was 2008. Of course, the idea has been around for much longer. This is not at all what we're building with smart cities. So this is sort of the theme now of the next few minutes as I finish. But what we're doing with technology is actually quite different. It's not the super engineered city, but it's something much more adaptive and much more interesting. So in some ways, the challenge ahead, when we look certainly at the rest of the world, is that we have now a commitment in the next 14 years, till 2030, from most nations, to really solve all the great problems of the world. As I showed you in the beginning of my talk, we only know how to address these problems, not solve them, but at least ameliorate them, through urbanization. So these are the Sustainable Development Goals. Many of you would know about them, but it's about poverty, hunger, infrastructure, environmental quality, equity, and many other things. And so the question is, how are cities to do what they've done, what you've done here in Hong Kong so successfully, now globally? So that's essentially the question. And the levels of money are also staggering. So this is an estimate, but it's saying how much money will be invested in cities, mostly in cities, to address these issues that I just described. So the idea would be something like that, $1.5 trillion a year between now and 2030. So there's a lot of potential money on the table if we know what needs to be done, which is probably not just build a Masdar city, but it's really think about how cities actually evolve and grow. So there are a lot of opportunities to measure things in places even like Cote d'Ivoire. This is cell phones. If you look at maps, this is South Africa. What you see is that it's cities. So if you know the geography of South Africa, it's cities that are nucleating this change. It's just a map that speaks to something I showed you before. This is cities of Brazil. It's from a recent paper that's still in review, but it's showing you basically that largest cities are solving these issues of water, electricity, sanitation, so physical services. But they're doing this with a high level of inequality, which is the y-axis. So we don't know how to create change without creating brutal inequality in many of these cities. So it's an interesting case. This is just about physical things, but I know that you know that if you looked at money, it would be even worse. In many places, we don't have money measures, but this is something that's happening, and that's measuring the kind of progress of Sustainable Development Goals that we're seeing. We have these new tools that allow us, for example, to collaboratively map places that have never been mapped before. So this is a slum in South Africa. We now see urban fabric that we've never seen before on massive scales like this. So these are all little shacks. It's a shanty town. But we now have information, and they have streets, and they have names, and they have numbers, and we know who lives there. It's kind of a special moment where that's becoming possible. We have a project to use this kind of data to propose street networks that provide services into these neighborhoods. So this is one example. It's called openreblock.org. We need some help with it if you'd like. Talk to us. But it's basically how do you build street networks in a way that's mathematically well understood, but also solves a very real problem. Charlie and I spent some time thinking about how technology applies to cities in the U.S., but generally this is a report to the President of the United States. Of course, the President is now going to be a very different president, so we don't know what happens. But part of this is actually how do you create an ecosystem of technologies that cities can collaborate to solve their problems while not having sort of the centralized solution like IBM was proposing, but nevertheless to have a whole system of innovation in the public space that solves the real problems of real cities collaboratively. When you look at cities in great detail, so again, my talk was structured like we're coming from the sky down to earth, you find that the problems of cities are very spatially concentrated. The problem of poverty, which you see here for New York City in terms of red, or the problem of crime, the problem of environmental degradation, are typically very local spatially. And so it's important to understand those characteristics and find solutions that are less blunt and more appropriate to the nature of the actual problem. So this is a big movement to do more and more of this, but that requires data and sensing at the very local level that's connected to the nature of problems. So the array of things that Charlie's building, I'm sure he'll talk about it, is one of the ways perhaps to go about that. So technology is changing everything, not so much in the hardware, but in the software. I find this article very interesting because it's through these ways of communicating and sharing information that we're now finding better solutions rather than building a better train. We're trying to discover more which train to take versus a bicycle versus other things. So it's this design of enabling technologies that is really making a huge difference. And it's creating sort of a sharing economy that allows people even to do things that they've always done in cities, but that allows them essentially to share services, share resources, and really create a market that's not only based on money, but it's also based on information, right? Reputation and other measures that are common in cities, but are being captured now in more efficient ways by technology. Finally, but not the least, is that there's the possibility of really having, in the next decade or two, a huge transformation of our energy system. But this, again, through solar panels and other measures are being done sort of piecemeal and not necessarily in a centralized way like Masdar. But we're starting to see country after country that's invested heavily to be powered for a few days on green technologies. And we're still trying to find now ways to manage these in smart ways, in real time, closer to demand. So again, this picture of coming to the small scale, but to be more efficient and smart in the management of information, also in the way we use energy and in other infrastructure that used to be, frankly, quite dumb and big. Okay? So this is my last slide. And it sort of is an outlook slide. But it's a slide that kind of is a little provocative, hopefully, and it's trying to project the sizes of cities till 2100. This is from Wikipedia, and I have problems with this data. This data basically is extrapolating present rates of population growth in continents and countries down to city levels, okay? But if you look there, and if you look especially, think about this region, the region of Far East Asia, it's the next decade, maybe 2 decades, that very large cities will happen in this part of the world. Shanghai, Beijing, a few other cities will become quite large. But when you look at these lists, not so large, because China will be hit by an enormous population slowdown, right, because of demographics. So it's a very interesting region where you've had immense progress and growth, as we described in the last 50 years, but where in the next couple decades, there'll be a very fast deceleration of that process. And issues of livability, issues of aging, issues of transformations in the economy will become paramount. Things that we've been struggling with in Europe and the United States, perhaps in Japan, for some time, but that you'll experience on a scale that's unprecedented and very interesting. On the other hand, you see the cities of India coming in sort of in mid-century, and the cities of Africa really becoming very large, which are places that are very poor, that have a very distributed model to management, and that may or may not create livable environments, but that are really the forefront of problems we need to solve. So as we look at the world of cities that we now already have, and we look at the transformations that we have had, I think the experience of Hong Kong is very relevant. It has been the city that has been in the forefront of this transformation, and that will continue to have to deal with that transformation in the next couple decades. So use what you know, make it systematic, use it in other places with imagination, and I think this will really be a great place to both think about cities and to work about them. So thank you very much. It's been a pleasure to be here, and let's talk more about anything you need to know.
Thank you, Professor Bettencourt, for taking us through the urban complexity and urban development process. Okay. Now we have time for questions and discussion. Is there any? Okay. Would you like some water?
Yeah, I need some water.
Thank you for a very interesting talk and inspiring talk. My question is, with the introduction of the online social activity, the cyber world, and the economic activities happening online, how would it affect the scaling laws that you show through the past hour?
So the short answer is that we don't really know. What we do know is that if you look at the situation now, and if you look what has happened in recent years, in many ways, cities are becoming more enabled by these technologies than disabled and substituted. So there's some economic activity like manufacturing and warehousing that's moving outside of cities. But a lot of these technologies that you've seen, from cell phones to the share economy, are actually facilitating many things that happen in cities, in large cities in particular. So if anything, I think a lot of these technologies, so the verdict is mixed, and it's a complicated story. But I think that a lot of these technologies, their biggest successes, are happening in large cities. So they're facilitating cities becoming more efficient, larger, and everything in the same superlinear sense that I was describing. We don't have a direct measure that is a controlled experiment that says, as I introduce this technology, this creates a change in how, in the productivity of cities versus that scale or something. But so what we do know is that in many ways, cities are being encouraged to grow and be more efficient through these technologies to a large extent. I think that the usual issue of what sectors suffer and what sectors prosper is very much on the table, and that's a longer discussion.
I have a question for you. So, although Chinese urbanization rate is around 50%, so the trend is clear. So they have more urbanization, a higher urbanization rate. So now we know the negative aspect emerges, such as air pollution, like haze in big cities in Beijing or northern China. So what's the suggestion for this kind of urbanization for mainland China?
Sure.
Thank you.
So I think that this is your moment, right? It's an extraordinary moment in Chinese history where you're becoming an urban country. And you'll become a developed urban country like many other countries, but you also have the challenges of transitioning, right? You're transitioning from very fast development with some issues of environmental degradation, which need to be addressed. If you look at India, it's already worse than you in many cities. So it's not a problem just of China. It's a problem of many fast developing urban systems. I think the nature of the problem is more or less understood. It's slightly different in different places, but it has to do with the use of fossil fuels, in some cases how you treat garbage, and a few other things. And so it's doable, but it requires political will and action. It's normal, but it needs to be addressed. I think on a historical note, every city or every system of cities, every nation that's gone through very fast urbanization has experienced some issues of environmental degradation. As we know, cities of Europe, like famously in England or the United States, had also a lot of smog. China's just much bigger. and it's a different time, so you use even more energy. So the problem is also just much bigger. And so it requires a much bolder solution and a faster solution. So, but the problems you're having are problems that will be, and their solutions will be useful in India, will be useful in parts of Africa that are going to go through the same problem. So don't just, while you think about solving your issues, solve also that you're solving an issue of all cities. And then you have to think about down the line, how the economy of Chinese cities, which many of them have been centered on manufacturing, and how, and transitional labor and so forth, how that becomes more of a situation that has scope in time, that people can continue to develop the economy in ways that won't suffer if those jobs move somewhere else, that are more livable, where people can live with their families. There are lots of issues of the Chinese city that are very interesting. They're part of your history, but they're also, you have to think about how you can create an urban system that's good for everybody and that's encouraging of creativity and so forth. And that's happening. I can see it happening, but you're just in a prerogative in history that no other nation had to do this so quickly on such a large scale. So your challenge is enormous, but the prize at the end of the day is also enormous. I think you'll have a wonderful society once you manage to solve these problems. So that's where we are. Sorry, there was a question here, and there was a question here too. Here. But I would love to know more about what you think are the actual problems or actual places and how they're being addressed. I read the news, I see that there's a lot of solutions in the works, but there's a lot to be understood.
Hi, Professor Bettencourt. Thanks for your exciting presentation. But I'm always skeptical about international comparison using official census data, especially cross-international census data. As you mentioned in your talk, the population size in Chinese cities is not really reliable. And the definition of city, whether we count a central city, whether we should count as metropolitan, how we draw the boundary, and that will affect the indicators of population, GDP, etc.
Sure.
So how would you consider addressing these probably not very consensus definition of city in your research?
Right, good. So, it's a classical question, methodological question. I talked through it in my talk, but essentially there are two issues there as I see it. One is, is the data that's given for whatever units that exist, what do we know about it, how reliable is it? I think this happens in every country, and it's just you have to know what the data is about. Okay, so you have to do that scholarship. I think regarding the definition of the city, all the definitions that we have to understand cities in the way I was describing them are these metropolitan definitions. So definitions where you're connecting populations not along political lines, but along lines of interaction, socioeconomic exchange. Okay? So I think that there's an effort in China to come up with these units. I didn't have those units. I had prefectural cities, and I selected urbanized districts. That's what I did here. So it's a first pass at that. I was encouraged, perhaps, that you get somewhat similar but noisy results using this data. But I think there's a lot of work to be done, and I'd love to talk about it, how one would better understand the nature of these places. I live in the United States. China is a continent. It's very hard to know that in great detail. But this is one of the reasons why I'm here. So I think that, but just to summarize, I think we know both at a principle, theoretical perspective what we are looking for. And I think that, the problem of work permits versus actual population and so forth is very well known in Chinese cities. Everyone discusses it. It's its own problem, right? How exactly both populations can move and what's the right thing to do. And so it's interesting to discuss. And you do find, on that point, characteristics of the Chinese city that are different from other cities. Like, for example, if you look at, I mentioned that quickly, but just to say it, if you look at employment versus population, you see it's a little superlinear, meaning that it's all, in larger cities you see a lot of workers, but it's partly because of this data, which emphasizes workers, right? So that's one aspect. You also see, interestingly enough, this also happens in other nations, but it's something I'd like to discuss with anyone interested, that the fraction of GDP that's going to wages is a little lower. So it's kind of hard on the workers as they're moving to larger cities. It looks like they're actually getting a smaller part of GDP. So the fraction of wages to GDP is lower in larger and larger cities, which is interesting. I think it's part of the structure of production of Chinese cities, which is large scale. But I think it's pointing to an interesting structural problem, which is a problem that may be real and important. So there are issues like this. But, the data is never perfect. You just have to know what you're dealing with. And you have to know what you would like, ideally.
Hi, Chris Webster, Hong Kong U. I was going to ask whether you'd found a way to interrogate causality in the right. Scaling and GDP, superlinear GDP population relationship. And then I realized you already have a natural experiment included in one of your graphs, which was the superlinear Chinese case.
Right.
So my question is, do you think that the supply-side-led urbanization that's really driven Chinese urbanization and arguably Chinese industrialization and economic growth has actually helped push that GDP superlinearity? In other words, might African cities in the 21st century be encouraged to engage in possibly Keynesian style infrastructure and city building in order to expand otherwise natural GDP growth trajectories?
Right. This is an excellent question, right? So let's talk more offline. But the answer, I think, as I see it, Chinese urbanization, for the points you mentioned, and you mentioned in your question too, is kind of special and peculiar. Maybe we can talk also about Britain when it urbanized very quickly, even the U.S. There were some similar stories, but perhaps not in the same systematic large scale. The industrialization, manufacturing became big factors, at least in the growth of some places. In China, maybe that's more widespread, and that's an issue. I think it is historically typical of places that did it very quickly, right, as China's done it. I don't think that is the main driver of superlinearity as we see it. It is, though, the driver of some exceptionality of some places, like Shenzhen, as you saw on the plot. So Shenzhen is, even in that picture, special, right, in terms of what kind of production it engages in. So you do see that in some ways. I think the issue then, which is a bigger issue of over time, what happens over time. I'm writing a couple papers on this, and this is a problem that's been with us since the beginning. It turns out to be easier to do these cross-sectional analysis than temporal analysis, right? Because the causality in cities is complicated. But to cut a long story short, what you do see is a lot of path dependence, as you would expect, and that the fact that what happened last year, even in China, is important for what's happening next year. So they have very strong temporal correlations. So what you see there is that in that plot that I show of Chinese cities, is that you can actually predict very well the next year from the previous year, even if you knew nothing else. But you only knew the overall, so nationwide economic growth and population growth into cities. So cities move together more than they move apart in funny ways, which is, I think, really being revealed by this sort of data and the fact that we now have some of it. For the United States, we have about 60 years of this sort of data, and you see the same effect, but much slower. But you see this path dependence, you see shocks that's system-wide, to use the language of economics a little bit, and you see specific shocks in specific places, particularly in places that are very specialized, like whether it's technology or fossil fuels. In the United States, you have cities that are all about fossil fuels. You see these with local shocks, but those shocks are less common. Most of it are system-wide shocks, very strong predictability from year to year, superlinearity being reproduced from year to year.
Population and the GDP, but I don't like GDP, And in China, we are talking about the green GDP.
Green?
Yeah, green GDP. From your GDP to reduce a lot of pollution,
right.
the money, something, right. The carbon money, then right. You can get the green GDP.
Well, I'd love to have measures of green GDP.
Also, you can use also incoming. The incoming may be better than GDP. This is my comment to you.
Well, as you know, GDP and income are somewhat interchangeable, depending how you measure GDP exactly. Okay. Oh, okay, I'm sorry. Let's see if I don't get all messed up. Yes, so I just had, GDP is good in the sense that measures the overall economy, both profits and wages. I've also, I didn't show you, but I've also looked at income from the same data set. Yeah. I do not have green GDP. I'd love to see what that is, how it's measured in China. Part of the problem of using that is that it's not necessarily comparable between nations and even maybe difficult to measure across cities consistently, but you have to tell me exactly how it's done. Maybe it is. So that's why. But what you find, as I mentioned, income and GDP is interesting because if it's wage income, so labor income, then you see that actually that's slightly less, but significantly superlinear than GDP, which means that in larger cities, this is also somewhat typical, but it's special in China because the effect is stronger. You see that there's more GDP accruing to profits of companies in larger cities than to wages by this data. I don't know how good the data is. But that's very interesting because I think it's also typical of a system that has a lot of finance and manufacturing as its driver, which goes to his point.
Yes, the reason is in China in the recent years, and the government want to do urbanization, let the farmer into the city. But the farmer move into the city to the high building. Their living cost may be not so good than in the countryside. In the countryside, they can get the vegetable, the fruit, the fish from the lake. Let them looks very very good the living the condition. But if they move to the city building, they should buy everything. There's no money. So in that case, in China, we're thinking about what is GDP, what is the incoming, what is the green GDP. Good. That's my comment to you.
So those are very good questions. Just to say something that should be clear, but just to say it, I don't know of data, but I'd love to see a cost of living in cities in China, for example. But I do know in the United States now we have a standardized measure of cost of living across these metropolitan areas. And when you look at real wages, so the wages that are counting for costs, okay, and this is just, again, an average across the city, you do find, of course, that the superlinear effect goes away. People make the same, in real dollars or in real money, they make the same amount of money in large cities and small cities, but of course they use it very differently. So people don't just have more money in their pocket in larger cities just because they make more money, because everything else also costs more money. But you do have more choice, which is interesting. And you also have a lot more, even the farmer, right? One of the issues with farming, perhaps in China it's been too long ago, but almost in every traditional society is that the farmer that's not connected to a larger economic system is very vulnerable. If the crop fails, if something else fails, they basically have a big problem. They may even go hungry. And once you become part of this more urban system, you just have a way where you have to specialize, you have to live in a high-rise building, but you have other choices that most people throughout the world, as we know, are preferring, given a choice to live that way versus live in the countryside in the subsistence living. I think often in every country, including the United States or Europe where I grew up, we tend to think that rural living is great, so natural and full of, good products, good food, but it's a very tough life, actually. Also a life often of poverty under certain conditions. So it's also how do you make these lives better, both in the city and in the countryside. But I'd love to discuss that more. Anything else? Any other question? There's one here.
I wonder, I can see a couple of saturation coming up. And I'm wondering whether this projection has taken into account of the saturation, the dynamic feedback of the constraint of the global, like carbon dioxide generations and the increase of education standard that will slow, hopefully,
yes,
the growth of population.
So that's exactly what, and I said I don't trust this data all that much, is what I meant. I think it has been, so every one of these nations is going through a demographic transition, right? Some are already in the books, like, in China, that we know sort of the policies that are trying to curb population. But with urbanization, even without any policy, you tend to have a very sharp demographic transition. People have fewer kids. They don't have space to have their kids. Kids need to go to school. We all aspire that our kids have more opportunities, so people have fewer kids. So yes, in this estimate, they have, you can read the paper, they have taken into consideration some demographic transition projection models, but I think they've not been aggressive enough, particularly for Africa. And this is why when you look at the right column, you see African cities mostly, and maybe some Indian cities. Is that I think that as you look now at the rates of population growth in Africa and South Asia, they're still fast. These are the last places where we still have fast population growth. But they're just beginning to urbanize. Most places are about a third urbanized. And I think that demographic transition, if you ask me, but I'm no demographer, will come more quickly than it's estimated here. But even then, 75 million people in one city. It's just amazing. Even if it's half of that in Lagos, it's extraordinary. So that's what we may be looking at. But even cities like Jakarta here in the region is going to become very large. So parts of Asia and South Asia will be very interesting going forward and full of problems, but also full of opportunities.
Okay. Time is up.
Good.
Any burning question before our break? Okay. 2 burning questions. Okay.
Thank you for the very interesting presentation with that much mega data. It appears to me that you put forward the argument that the growth in the scale of the city is a positive factor in improving the human development, particularly illustrated by the Human Development Index. But I'm just thinking whether there is a threshold. When people concentrating in the city, it is very much like concentrating human energy in a city. And an example is like the nuclear reactor. Mm-hmm. Yep. If we have a system can regulate, the interplay of that energy, then that can be positive. Right. But if that regulation, laws is controlled or derailed, then this concentration of human energy can be disastrous. So I'm just wondering, for example, when I look at the Lagos, it is in Nigeria, right? Mm-hmm. Well, it will become the most populous city in the next century. And I just wonder whether in your model of predictability of the cities, whether we can also predict, how these countries can develop the system to regulate this concentration of human energy and turn them into some sort of positive factor.
Right. So it's an important question both about the limits of the sizes and goodness of cities, but also about who manages that, right? Is that managed by a government, for example, or is that managed in some other way? So to the first point, I think the 2 points are connected. And the point is that in most places, cities are not like nations. They really are a self-regulating environment in that people, if a city becomes too polluted, too dangerous, too expensive, people don't come anymore. So this speaks to a socioeconomic mechanism by which the size of the city is being essentially self-regulated by its environment, its costs, in economic terms, but also in other terms. So that's usually what happens. What happens in a place like Lagos and in many other places is that even though we may look at Lagos from the perspective of Hong Kong, or the perspective of an American city or a European city and say, oh my gosh, how can all these people be coming here? The fact is in Nigeria, it's a good city. It's a city full of opportunity. So you have to put it in context of other cities and rural areas in the same country or region. And that's when it makes sense. So that's essentially the issue. It's the same thing. We make that mistake over and over and over again. People will say that about Chinese cities. They'll say that about African cities. They say this about many American cities. How are people coming to Phoenix, Arizona? Well, actually, it's sort of interesting city in some ways, but it's growing very fast. So this issue of understanding better the growth of cities is still on the table, amazingly enough, even though we've done all this work for a long time. Michael's done wonderful work about that, but it's still something we don't understand very well. One thing we do understand that's coming from new data, which is interesting, and I wonder if you have data about that here, is that the actual net growth of a city in terms of population, so if a city grows by 5% or 2% or 1%, is much, 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 much smaller than the people that are coming through. So all the time there are people coming and going, coming and going, coming and going, and of that, only a very small fraction is staying that contributes to city growth. So, in other words, there's a lot of experimentation. People are trying it out, seeing the city, seeing if it's possible to be there, and at least within a nation. And if they can, then they can stay. But in some ethnography, so these are just more anecdotal data, it's thought that people that try to come to cities, actually this I think are some ethnographies of Chinese cities in part, only half of them stay. So people try it, and after 6 months or a year, if it doesn't work out, they go back to the countryside or a smaller city where they came from. And so that's sort of interesting, and it speaks to the self-regulation. Of course, in places like China with the work permit system, you have a much more explicit way of trying to control at least labor migration. And of course, Hong Kong in its history has also had a border. Same thing is true for Singapore, right? So there are places that have more explicit political mechanisms to do that. But the self-regulation of the system is very important.
For the interest of time, Professor Ng, would you like to save your question to the...
It's not much
Okay.
Rather a kind of naive comment, if I can, or disruptive comment.
Please.
Yeah, sometimes I do that. It's very similar to Professor Lee's comment. I look at the CO2 capita and some of the other graphs, that the axis is extremely simple, X and Y, and then you try to compare the city across the time and things like that. Bear in mind the notion of complex system, whatever.
Sure.
The meaning of the dots and the meaning of the axis changes over time, and the meaning of agenda changing over time. And if you put all these things together based on very simplistic kind of XY axis, the interpretation could be very wrong, because I actually emailed this CO2 Hong Kong versus Singapore to our secretary.
Okay.
And he came back, and long email, by the way, said it should not be looked at that way because blah, 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 and all these other things comes in and to explain that or to interpret that data. So I just wonder, given the notion of compact system, should those things be so simplistically represented and therefore interpreted? I see a lot of graphs that are very simple.
Good.
But, yeah.
I think that's a fair question. I think that if you're going to measure a system in any dimension, right, these are some of the dimensions in which cities have been measured. And I think you need to measure things, right? So it's fair enough to measure CO2 emissions. It's fair enough to measure GDP with all the caveats. It's fair enough to measure people, right? Or area. And so all these things are aspects of it. However, hopefully in my talk I made the point that these things are interconnected. So when you look at an XY plot, there's a Z and other dimensions that are happening all at the same time. And in my work I tried to create theory and models that show how that happens. There's a lot more work to be done. But that would take a little longer. But hopefully you saw that it's the fact that you can create a larger city with certain patterns of occupation of land, of energy use in transportation and so forth, that then allows people to specialize, to interconnect, to have different kinds of jobs. And so all these things are interconnected and are somewhat predictable. But they're still simple at their core. What are the drivers of these transformations? That was part of the point I was trying to make.
You think it's simple? The drivers are static and so simple?
At some aggregate level, yes. I think ultimately they are. I think in detail there's a lot of choice, there's a lot of accident, there's a lot of history in each one of our lives, in the lives of each one of these cities. But when you start looking, if I ask, what's going to happen in Hong Kong next year if I know Hong Kong now, and if there's no big shock internationally, I can tell you a lot about Hong Kong. And, because the point about this is that despite the fact that what I showed you being relatively simple, there are things that force us to be relatively simple. So, for example, money is one dimension, space is another. But you need to balance your money in your bank account over a certain amount of time to exist. And that means that you can only consume and do a certain number of things, given your income. And your income is also connected to the job you do, which is in the city. So once you bring these things together, you have a lot more predictability, even though these things are all interconnected. About CO2 and your minister, I'd love to have that conversation. It was meant to be a little bit provocative. You should take heart that Hong Kong did very well for a long time, but not in the last few years in relation to Singapore. I'm sure you know it because you're sort of somewhat neighbors. Singapore has been very aggressive in terms of all kinds of policies to reduce their CO2 emissions. And so I think you're seeing a little bit of that. And that's good. But, that's good. So I hope your minister is motivated. But CO2 is simple to measure, and it's physical. It's energy and emissions. So it's a complicated accounting thing. But we can certainly, it can be done. And cities throughout the world now are doing this systematically. So, Hong Kong has always been very efficient in traditional terms because it's dense, it has a lot of public transportation. It's not as tropical as a place like Singapore or cold as a place like New York. But, now that we're getting more ambitious with those objectives, there's the question of, what can be done.
The notion is that, the notion is basically what Professor Lee was talking about. Actually, the measure, he's talking about green GDP. You should not measure GDP anymore. You should measure green GDP since 2000 something. So the meaning of the axis actually changes. So therefore, if you use the old way of accounting, then of course it will go that way. If you use a new way of thinking, it will still go this way. We are doing better than Singapore.
I'll say two things. I'll say that by all means, if your definition is good, let's do it. But if it's an excuse to not do better, then let's not do it.
I think that is his excuse.
Okay,
Thank you.
may I suggest that I can start I can see the beginning of
A good discussion, right?
a good discussion. Okay, but we will have the opportunity later on this evening. No, later on this afternoon, when we have the discussion section. For the interest of time, please join me to thank Professor Bettencourt again for the interesting talk.